A pleasant greetings to all. In this video, I am going to explain about D flip-flop. The major drawback of SR flip-flop is its indeterminate output when S is equal to 1 and R is equal to 1. This is overcome by the D flip-flop. The D flip-flop is otherwise known as data flip-flop and it can be also called as delay flip-flop. The logic symbol and logic diagram for D flip-flop is shown in figure. First, I am going to explain the logic symbol for D flip-flop. Input is D, output is Q. And our Q bar is the bar value of the output obtained. CP is the clock signal given to the D flip-flop. This is the logic symbol. Next, I am going to explain about the logic diagram. Next, I am going to explain about the logic diagram of D flip-flop. How the logic diagram of D flip-flop formed? By the combination of 4 NAND gate. 1, 2, 3 and 4. Din is the input given to the NAND gate 1. And output of the NAND gate is connected to input of the third NAND gate. Output of the second NAND gate is connected to input of the fourth NAND gate. And output of the third NAND gate is again connected to input of the fourth NAND gate. Output of the fourth NAND gate is connected to the input to the third NAND gate. And Din is connected to the second input of second NAND gate via the inverter. These are about the logic diagram. And next, how to form the truth table from the logic diagram. First, Din is equal to 0. And then Qn value may be 0 or 1. I have directly take the value Qn and find out the next state. Din equal to 0. What is Dn bar? That is 0. Bar is 1. Clock pulse is 1. Here also 1. 0 into 1, 0. 0 bar is 1. 1 into 1, 1. 1 bar is 0. Here Qn. Qn into 0, that is 0 bar 1. 1 into 1, that is equal to 0. So the output equal, the next state equal to 0. Whether it may be 0 or 1, will get 0 only. This is the reset state of the flip-flop. Next, condition number 2. Input D is equal to 1 and positive clock. Or clock equal to 1. Input D equal to 1. What about the output of this inverter? That is 0. Clock equal to 1. Here also 1. 0 into 1, 0 bar, that is 1. 1 into 1, 1 bar, 0. Here Qn into 1, that is Qn bar. So this Qn bar is multiplied to 0, Qn plus 1 equal to 1. So Qn plus 1 is the next state, obtained equal to 1. So whether it may be 0 or 1, the present state may be 0 or 1, we will get the output as a higher value. This is the set state of the D flip-flop. Next, case number 3. The input may be 1, 1. Present state may be Qn and clock pulse equal to 0. So 1 into 0, that is equal to 1. 0, 0, that is equal to 1. Now Qn into 1 is equal to Qn bar. This Qn bar is multiplied with 1, that is equal to Qn. So no change in the state at all. So there is no change in state. These are about truth table for the D flip-flop. And next, I am going to explain about K-MOF simplification and how to find out Qn plus 1. To find out Qn plus 1, I am going to take D and Qn. From this, I am going to find out the derivation of Qn plus 1. So D and Qn, there are two variables. 2 power 2 4-cell Carnot map is needed. D in the y-axis and Qn in the horizontal direction. Put 0 and 1. Here also 0 and 1. D is equal to 0, Qn equal to 0, Qn bar is 0. D is equal to 0, Qn equal to 1, Qn bar is 0. D is equal to 1, Qn is 0 and Qn bar is 1. Sorry, Qn plus 1 is 1. D is equal to 1, Qn is equal to 1, Qn plus 1 is 1. Now I am going to combine the neighboring cells. Here two cells are combined together. The answer is D. Here there is no common term. Here we are having D. This is the K-map simplification. And next I am going to write the function table. Function table is D is equal to 0, 0. Both are 0. Qn is 0. So both are 0. No, 1, 0 you have to take into account. Here that is 0. And both are equal to 1. Output also 1. So D is equal to 1. Output is 1. So it is known as data flip-flop. The reason is whatever data given to D will get the same as the output. So this is the data flip-flop. And next I am going to explain how to draw the excitation table. To draw the excitation table, first column take the element Qn, second Qn plus 1, third is D. First Qn, 2 zeros to 1, 1 0 1, alternative zeros and 1 you have to write. And 0 and here both are 0, D is equal to 0. 0 and 1, D is equal to 1. 1 and 0, D is equal to 0. Both are equal to 1, D is equal to 1. This is the excitation table. From the excitation table, we can draw the state diagram. To draw the state diagram, first put two circles, 0, 1. This indicates present state. Okay, 0 and 1. When D is equal to 1, the set state is in the flip-flop. D is equal to 1, the state from 0 to 1, 0 to 1, that is set state. And D is equal to 0, it is from 1 to 0. 1 to 0, D is equal to 0, this is a reset state. And next 0 and 0, D is equal to 0. And 1, 1, D is equal to 1. That's all. This is the way to draw the state diagram. Thank you. Have a nice day.